Hi guys, I'm Sai. So I'm here to talk about using Postgres and Citus for lightning fast analytics. Before I get started, a quick intro about myself. I'm Sai Srirampur and you can call me Sai. I'm an engineer at Citus Data and hence I'm now part of the Microsoft family, and I'm very excited with this because I would be seeing more and more use cases. The reason I joined Citus is to make it so that developers never have to worry about scaling their database. One quick fun fact about myself is the last time I did this webinar, it was right before my wedding, and now it's right after my wedding. So let's see how the marriage experience goes. As Claire mentioned, I have a couple of Twitter handles. One is my personal Twitter handle. Next is Citus's Twitter handle. Feel free to go ahead and tweet the webinar. So before we go into the demo and session, I just wanted to point out some of the common problems which we hear from customers in the real-time analytics space. So the first is they have an analytical engine which does reporting on more historical and old data, but they want to get the ability to query more real-time, recent, and latest data. So this problem relates to maintaining the freshness of the data at the reporting engine level. The second problem is, this is a more common problem we see, is they have a single node Postgres database on a very beefy instance. They have already reached the limits in like vertically scaling up, but still they are running into performance bottlenecks with respect to their dashboards being slow, their reports being slow, etc. And the third problem is they have separate stores for analytics workloads as well as separate store for transactional workloads, and it's becoming a hassle to maintain both of these stores, and they want to have a single system of record to ease this off and have both analytics and transactional workloads in a single engine. And to solve all these problems, we have Postgres powered with Citus to do the job. And the reason why Postgres is because finally Postgres is an open source database with a very rich feature set. Like you have extensions like HLL, Top-N, Citus. You have very rich geospatial features because of the Postgres extension. You have very rich SQL functionalities like window functions, CTEs, full text search, JSONB, etc., etc. And the second angle is why Citus. Citus is because it transforms Postgres into a distributed database. So what Citus does is, Citus lets you shard your data across multiple Postgres databases, but for the end user, it looks and feels like a single node Postgres database. And as you are basically sharding, splitting your data across multiple Postgres databases, you inherently scale all the resources, both memory, compute, as well as disk. And then the second thing is Citus also lets you parallelize your queries across multiple machines, which tends to giving linear performance benefits. And last but not the least, Citus is an extension to Postgres by which you get all the latest features like JSONBs, HLL, and also the latest Postgres partitioning feature, which is a part of Postgres 11 working with Citus. You might be thinking on how we could get going and test Citus. There are three offerings which we do. First is the database as a service offering, which is called Citus Cloud. So with the sharding, with the parallelism, with the horizontal scale functionalities, we also wear the pager to take care of the database. So we take care of backups, we provide high availability, we provide logs, we provide metrics and external integrations as well with Citus Cloud. The second is our enterprise offering, which is where you buy the licenses from us and deploy it on your own hardware. And you also get enterprise level features with the enterprise software. The third is our open source offering. This is where you can download our packages or like use the Docker images to test out Citus. So here I have our GitHub repo, and looks like we have around 3,300 stars now. So feel free to go ahead and check this out and lend a star as well. So, okay. So before I go into the demo, just wanted to give you a quick overview of Citus architecture. In the Citus world, you have something called as a coordinator node, and you have something called as worker nodes. The coordinator node and worker nodes are nothing but a simple plain PostgreSQL databases. For the end user, all of this architecture is abstracted away and it looks and feels like a single node Postgres database. So the coordinator node orchestrates your queries to the right worker nodes, and the worker nodes are the nodes where the actual data exists. That's where the actual computation happens. So from the end user client perspective, what you do is you go ahead and create a table as you generally do with Postgres. So let's say we create the campaigns table. Once I create that table, Citus gives you a simple API, a simple SQL function called as create distributed table, which lets you shard your table, here campaigns, on a column. So let's say that we shard the campaigns table on the company ID. So once I run that command, what Citus does is Citus creates shards, the green ones which you're seeing here, and across the worker nodes. And shards are nothing but simple plain PostgreSQL tables, which hold a set of data, here a set of companies. So it's very similar to consistent hashing, if that makes sense. So if there is a query which is related to a single company, then what Citus does is Citus routes the query to the right worker node and execute the query. But then if there is a query which spans multiple companies, similar to what you're seeing here, an aggregate grouped on company, what Citus does is Citus parallelizes your query across multiple worker nodes and then gives you the result. So the main reason you're getting performance benefits is twofold. One is you have a smaller table, smaller indexes, by which you would see like better resource utilization, better index hit rates, better cache hit rates. And number two is because of the virtue of parallelism, that Citus parallelizes a given query, say it be a join, say it be an aggregate, across like multiple workers, and gives you the results. So all this logic of, okay, if it's an average, let me do a sum followed by a division. If it's a count, let me do a count followed by sum. If it's a sum, let me do a sum followed by sum, is built in the Citus extension. Okay, so let's go to the demo part. So what I did for the demo is I spun up two databases. One is a 4-node Citus database cluster with the hardware config as you're seeing here, using our managed service offering, Citus Cloud. And then side by side, I spun up a single node Postgres database. And the plan for the demo is we would run queries in both the databases, the distributed as well as the single node Postgres database, and do some benchmarks. So the queries which I'd be running would be very typical queries which you see in analytics workloads. So the benchmarks would be around loading data, creating indexes, both B-tree and GIN, and also running these query patterns in analytics workloads, which involve like group bys, aggregates, joins, etc., etc. And I'll compare it with a single node Postgres database. So what I have here is I have two windows, as you're seeing here. So the first is the distributed part, where I have two tables, events and users, on a 4-node Citus database cluster, right? This lower window is tables on single node Postgres database. Both the tables are same, events and users. And this is what you typically see in say analytics workloads, right? Where you have events, logs, etc., etc. And one thing which I did before the session is I created a schema in both the databases, and also loaded data in both the setups. And as I mentioned to you before, one thing which I did extra in the Citus part, in the distributed part, is I ran this command, the create distributed table command, which shards both the tables, events and users, on the user ID column, right? That's the sharding key. Okay. So as I said, I created the tables and loaded the data as well. One performance benchmark which I did was the copy command. So this is the copy command, the traditional copy command in Postgres. And this copy command, if you see, took around 46 seconds on a distributed table, right? Whereas this copy command took around 103 seconds on the single node PostgreSQL table. So with the bulk copy command, you see probably close to 2.5x performance improvement on Citus than compared to single node Postgres. And conceptually, this happens because this copy is fanned out across all the shards in parallel, by which you see like good performance gains, as you're seeing here. So let's get to the queries part now. So the first query I would run is a simple count star query. Okay. So let me run this query. And then if you see, it took around 45 milliseconds to run on the distributed table. And let's do the same thing on the single node Postgres table, and it's still running. So let's see how long this takes. So it took around 11 seconds, and I think it's because the data is in cold cache, but then let's run it again. And then if you see, it took around 210 milliseconds on the single node PostgreSQL table. So if you observe, you saw almost close to 5.5x performance improvement in the distributed setup than compared to a single node PostgreSQL database. And the reason this happens is because what Citus does is it basically does a map reduce. So if you look at the explain plan, it runs the count in parallel across the 32 shards, gets those 32 counts, and then sums them up on the coordinator node. So by this parallelism, you see like those linear performance improvements. And the query plan is very straightforward. It uses the real-time executor, which is a Citus executor for like running these queries in parallel. You have 32 tasks, but then this is just one task. And under the covers, the task is very similar to what happens in Postgres, right? Because this task is on the partition or the shard or the PostgreSQL table, which holds a set of your data, right?
Sai, there is a question for you. Somebody's asking if there's any reduction in size of these tables in single node Postgres and in the Citus distributed database.
Got it. That's a good question. So there is no reduction of the size of the tables in both the setups, because finally we are an extension to Postgres, and under the covers, these partitions are like plain PostgreSQL tables. But one thing I'll say is finally, as you're partitioning your data, your tables, the shards are much smaller, your indexes are much smaller, by which the probability of them fitting in memory increases. So let's go to the next query. And first is a simple create index statement. And this is a index on the event type column. And this is a simple plain B-tree index. So let's go ahead and create the index on the distributed table first. And let's do it also on the single node Postgres table. And if you observe, the create index command took around 393 milliseconds on the distributed table, and it took 1.5 seconds on the single node PostgreSQL table. So you see close to around 4.5 to 5x performance improvement on the distributed setup. And the reason is because all these operational commands like create index, vacuums, etc. are parallelized across multiple machines in a distributed setup, by which like you see vacuums running much faster, you see these like create indexes running much faster in Citus. So let's go to the second create index statement. So this is where I'd be creating a gin index on the payload column, and payload column is a JSON-B column, and this ties into Citus being an extension to Postgres, by which these latest types like JSON-Bs would just work out of the box. So let's go ahead and create this index on both the setups. Okay, cool. So let's wait for the index statements to finish, and let's see how long it takes.
So Sai, the one you did a minute ago, that was a B-tree index, is that correct?
Yes, that's the first in the sheet. So yeah, the B-tree index. So looks like the gin index creation on the distributed table got done in around 9 seconds. And the create index statement on the single node PostgreSQL table is still going on. So let's wait for this to finish. And the create index statement on the payload column took around 118 seconds on the single node PostgreSQL table. So you see a performance improvement of close to around 12x, right? If my math is not bad. So yeah, around 12x performance improvement on Citus than compared to a single node PostgreSQL table. So let's go to the second query. This is where I would actually run an analytics query where I would get an aggregate on one of the attributes of the JSONB column and then group it on the hour field. So this is very similar to a graph which you generate on your dashboard, right? So you're showing a graph at an hour granularity. So let me run this query. So this took around 85 milliseconds on Citus, and it took around 762 milliseconds on the single node PostgreSQL table. So you see a performance improvement of close to 9x on Citus then compared to single node PostgreSQL table. And the concept is again same. So if there is an aggregate, what Citus does is Citus runs this aggregate in parallel across all the shards, gets those aggregates, and then again aggregates them on the coordinator node. So that's what you see here. So it uses the real-time executor. There is a task count of 32, and then you have this aggregate running in parallel across the 32 shards, across the 4 distributed nodes, and then it gives you the results. So all these optimizations of, okay, if there is an aggregate, let me push it as an aggregate so that like I reduce the network flow from workers to coordinator is all in the Citus extension. So all these optimizations are already like in the Citus extension. So next, let's run a join query. So this is where I would join the events and users. And I also have an aggregate here where I get the top 10 users who created the most number of repositories. So let's go ahead and run this query. So this query took around 93 milliseconds on Citus, and this join query took around 417 milliseconds on the single node PostgreSQL table. So you see close to around 4.5x performance improvement on the distributed setup then compared to the single node PostgreSQL table. And let's run a quick query plan because that would be interesting. So here, if you see, there is a join query, right? So as I sharded both the tables on the user ID column, Citus automatically makes sure that these tables are collocated. And what I mean by collocated is shards holding the same set of users, because I sharded on user ID would reside on the same node. So if I have a join across these 2 tables, Citus pushes this join down and executes the query across like the multiple workers. So that's what you see here. So you see the Citus real-time executor, which parallelizes the query. And then here, this is just one task. There are 32 such tasks, but this is just showing one task. And then here you see the aggregate, you see the join as well. And here it uses a hash join. And then if you also observe, it uses the index which we created. So it uses the index on the payload column. And the index is also much smaller, right? Because this index is on the shard. So these indexes are smaller, by which like you see good index hit rates and cache hit rates. Awesome. So these were the queries I wanted to run. So I'll bring up the sheet once just to summarize the benchmarks. And you see that on an average, Citus performs close to like 5 to 6x or like 6 to 7x better than single node Postgres setup.
And just so y'all don't know that that's not canned, I was filling that in on the fly as I ran the live demo.
Cool. So just to sum it up, the benefits which Citus offers are number one, it parallelizes your queries across multiple machines and gives you linear performance benefits. Number two is the linear scale feature where you can keep adding smaller nodes to your cluster and rebalance data all in an online way. So you don't need to take any downtime with respect to reads and writes whilst your data is moving from one node to the newer nodes. So this is the horizontal scalability aspect. The third is you can maintain freshness of data. So you can have like real-time inserts, updates, etc. happening on your system. And then you can have a reporting engine which queries more real-time and recent data. And also concurrency piece. So we have, as like we are dependent on Postgres, you can have like very large concurrency. So we have many customers like large concurrencies close to like 500,000, etc. And then the fourth piece is you can run both transactional as well as analytics workloads in a single database. So now comes the interesting part where I will bring up a couple of customer use cases and explain how they use Citus in production. One of our largest deployments with respect to data size is Heap analytics. So they use Citus to power their reporting engine, which helps you do behavioral analysis on users who use your website. So it's a typical segmentation kind of workload. And they have a Citus cluster close to 70 nodes now. And then they have 34 terabytes of RAM. And then the data size, which is not mentioned here, I think is close to a petabyte now in that cluster. And they have 700 billion events in Citus. So segmentation use case is something which we are seeing quite often. Like we have a couple of customers doing segmentation using Citus. So you can check out the customer story to get a more detailed analysis on how the use case looks. The second customer is Freshworks, and they use Citus to power their real-time chat analytics tool. So you as a business can go and run your chat using Freshworks, and then they have a dashboard which provides analytics across the chats happening in your business, and that's where like Citus comes in. Under the covers, they use Citus Cloud as the database of choice. And then this use case is a multi-tenant analytics use case, because finally businesses use their application. And then the sharding works in a way that we sharded on the customer ID, the tenant ID. And finally, your analytics queries are routed to the right worker node where the customer is present. And it's run on the smaller tables with like smaller indexes, etc. And majority of their queries, 95% of them, take close to 20 milliseconds. And then they have close to like 500 million events in the table. So you can check out the customer story on our website. And next is the interesting use case where Microsoft uses Citus to power their Windows telemetry reporting engine. So they get data from they get metadata from Windows operating system usage, and they have reporting dashboards which queries this data. And then this use case is a very typical roll-up kind of use case where they do pre-aggregations at the database layer. So they have raw tables and they have pre-aggregated tables, they have aggregated tables, and then they run these pre-aggregation jobs which aggregates data from the raw tables to the aggregated tables. And then they power their dashboards from these aggregated tables. And one interesting term which comes to my mind is incremental map reduce, and this was something which the engineer who built this architecture came up with. So it's incremental map reduce which is happening at the database layer, and the reason they get good performance benefits is because that particular roll-up and aggregation operation runs in parallel across all the worker nodes. And the scales we are looking at is pretty huge. So they have a very large cluster with close to 700 cores across all the worker nodes, 4 terabytes of memory, and then they have close to 100 terabytes of data in the cluster. So there is a talk as well on this topic. So please feel free to check out our YouTube channel and get this video. So the engineer spoke at Postgres Open Silicon Valley. So. Awesome. So now I'll pass it to Claire. So, yeah.
Well, I was just going to highlight that the big news in January, if you missed Sai's introduction in the beginning of today's demo, is that Microsoft has acquired Citus data. And yes, what that means is that in addition to all of the Citus goodness and the things we already do with Citus open source and our database as a service and our enterprise software, our engineering team is working really, really hard to bring Citus to Microsoft Azure. So if any of you want to stay in touch with what's happening with Citus on Azure, Teresa is putting up a poll right now. And if you say yes, we'll be sure to keep you in the loop as things unfold. So nothing too frequent, but I know that some of you have been asking, so this is a way to kind of stay connected. Sai, I think you had a couple of more slides that you had after this.
Yep.
And I know we've got questions that we're going to go to answer, but what is the next slide? Remind me.
Yeah, so this is the summary slide, Claire. So one thing I'd say is Postgres plus Citus would help you scale your real-time analytics apps. So feel free to go ahead and check out Citus. So I have a couple of links here. One is the open source download link where you can download our packages and get going with Citus. Next is our managed service offering. So our managed service offering lets you create dev clusters, which are smaller in size. So sign up and spin up a couple of dev clusters and see like how Citus looks. Last is our public Slack channel. And this is a very active Slack channel because there are a lot of like interesting topics related to both Citus as well as Postgres. So go ahead and sign up on our Slack channel and please feel free to ask any questions on the chat. So.
Thank you, Sai, for putting this together. I really appreciate it.
Absolutely. Thank you, Claire.
Thanks, Teresa. And thanks, everybody, for joining us today.